the style of that one 5 minutes thing. Um, so this is what we did. It's not done. This is the main. And this is the hanging wall of the main domain. This is the foot wall of the main domain. So I'm still ignoring the hanging foot wall points, just trying to smoothen it up, which is already the part 5, the video of the part 5 video. So what I'm going to do is I want to introduce you to the vein boundary today, and we continue with the intrusive modern. That is the SAS case. So let me clean this, then bring this back. If you drop the main domain, you see vein boundary, main boundary. It's empty. So before you do that, you just have to. Why you are doing this is just to minimize from your 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 wireframe. So I will put the hangover focal point. That is the samples. If you make it transparent, you have realized that the up part is waste and the lower part is also waste, which we don't want to use that for our estimation. So first of all, we have to right click and then adjust our plane. This one is just like the reference surface where you adjust. So the F is front and the B is back, whichever way we want to do it. That is it. You can flip it by using. I won't do the ASP. We told you that the yellow one shows the dip, and then these ones shows the strike of the ore body. So once you know that, at times, because this one have clipped it to the main points, that's why you see it very flat, just like it. There are some, they are far away. The plane is far away, which you have to pull it using these arrows. You pull it, you can pull it where you want. So if you are satisfied with this, you just have to go back there. Just okay, go back there and pull it. You pull it, you see that it's lying on it. It's mimicking the orientation. So just make it transparent. You make it transparent to be able to see the hangover for more points. That's the samples. So if you do that, you just right click and go to edit. You adjust it first, then you edit it. You click on, see that pencil, edit, the points. So you just digitize it around it, take off the width that you don't. So I just on it. So just in, I can go back to the array for once. Just zoom only from whether you are doing it clockwise or anti-clockwise, there's no problem. So I just want to trim this one off. Then I save it. Just random. So we've cut the portions that need out. The total will also come and then shift portion out. So that's it for this one. Very safe for the hanging wall. Drop it. Make it transparent. Because of the interactions, you will see that I just left that when I'm editing, you will see how I'm doing it. Because of the interactions, these samples are entering the main domain because the main domain is priority. So because they are entering that domain is chopping those off, even though they are is so these samples are recognized to be inside the main domain. So that's why you don't see wireframes around them. You can decide that the main domain will envelop them, then you use it. You can decide to reassign them out of the main domain, or use a polyline to just demarcate them off the main domain so that the wireframe will be formed around these small samples, whichever way you want it. So places like this, you just have to cut this one off using the vein boundary. This one needs to go off. So if you pull it, it's already, because the reason why I'm saying, if let me double click on this and just show you something. You see that the reference surface is curved. It's using the midpoints of the samples. If it is on planar, it will be far away from it. Usually when you start your first editing, it's good to put it on planar. That one is easier editing. Then after that, you send it back to the curve reference surface. The ASP and then the share that we always want a smoother, very smoother wireframe. So we put it on the planar reference surface. The planar just mimic the orientation of the ore body. It's not exact, but the curve one is just using the points. So you see it mimicking exactly how the ore body is oriented. So it's more accurate for the curve one than the planar. The planar one is, the curve one is more accurate than the planar. So I just have to edit it using that one. Okay, so I just at times if it is if this wireframe is going to be used for update in future, fine. But if for the purpose of estimation, we can go this way, take this off. Go this way. So I want to capture these samples. Control Z. Okay. Last one is this one. Put the points in. Can make it just increase the points to be able to see them well. Okay, so is there understanding on what I'm doing?
Everyone is fine.
Yeah, correct.
Yeah, I was asking whether there's understanding on what I'm doing.
Yes.
Yes, please.
So the vein boundaries I'm constructing, if in future you are going to use these wireframes, you have to remove them. Otherwise, if you update the wireframe, it will not work for you. Yeah. So this is these are the domains we've come out with. So these days, some people are not comfortable using, for example, the main domain hasn't been pinched out. You may not be comfortable using it to estimate. So what they do is go inside the subdomain. Subdomain based on the grade. For instance, we have 0 to 0.5. Then we have 0.5 to 8. Then we have 8 to ceiling, which is our MF. So you enter inside this main domain, then you subdomain it. So you have wireframes for 0 to 0.5, then you have 0.5 to 8, then you have 8 to ceiling. That is your MF. So you're going to have the wireframe for the 0 to 0.5, the wireframe for 0.5 to 8, then you have 8 and above. You have 3 wireframes inside this, and then you estimate them differently. Then after that, you add mode them. And when you're add moding them, of course, the 0 to 0.5 will come first, followed by 0.5 to 0.8, then followed by 0.8 and above. So the 0.5 to 0.8 will superimpose on the 0 to 0.5. And this 0.8 and above will come and superimpose on the 0.5 to 0.8. Then you have your full model. So in that case, you've estimated them differently. You've subdomained them. This is what we call the domaining. So you enter inside the domain and subdomain. And domain again, that is called the subdomaining. And that approach is using the numeric model approach. So I just want you people to have to listen to the video and understand it properly, then we will subdomain. That one is just very easy. And this is the difficult part. The remaining ones are just easy. One day work. So we shall finish with all the wireframes approach, and then we pick a domain and then run the estimates on the various estimation methods. So we have more than 30 minutes. So I'm just going to introduce you to the ISASI own, how the ISASI model came, how the ISASI model is being done. This approach is for that of Akwesisu and Nkra. Those kind of deposit vein style, this approach is suitable for them. You can use this one for ISASI, but you have to be careful. You have to be careful because of the erratic nature of the deposit. This one, you have control. The veining approach, you have control. As a geologist, you have control, but the ISASI one, the control is less. Okay, so let me remind you again that anytime you are creating a geological model, you should have your mesh table. Each model has its mesh table. You don't use the mesh table for the pyrite or the sulfur boundary and create for the shears. So once we go to do that, I'm going to create a merge table for that one. So you just right click and then say merge. The lithology is merged once. The lithology is grouped once. But the merge table, anytime you are creating a geological model, you should have your merge table. So I need my assay. Even here, the lithology is not more of important because we don't need it. So this is fine. So I just have to say the underscore match. So then you okay it. So when you are done with the merge table, you just drag it and drop. If you drag it and drop, then this is your axis. We created the legend long. At the time we're doing the ASP boundary. So that's the legend. You just have to play with this, make it solid. So this is the cylindrical form, but the radius is big. So what you just need to do is reduce the line radius to 2. That will be 5 for it. So that's the drill holes. If you finish creating the merge table, same as the others, you just have to create your interval selection. Okay. So just from the merge table, right click and pick your interval selection. I just want to give it indicator. The base column will remain as none. So your form has appeared. So that's the indicator. These are just the traces of the drill holes. So just have to change to my axis. Over here, we are just using the cutoff. Isasi is using the cutoff of a 0.2 grams and above should go inside the shell. Then 0.2 gram, below 0.2 go outside the shell, and that is your waste. So I just have to. This one you don't step through to select section by section. You just have to use this to select all visible data. The reason why, okay, so let me do it this way so that you understand. If I say I need 0.2 and above for my wireframe, that is my ore. Grade that is 0.2 and above is my ore. It should go inside the shell. So I just have to filter here for 0.2. So all these are 0.2. 0.2 grams and above. So if I do that, I just have to use this. Select everything. So if I select everything, I just have to give it, create new lithology, say in shell. I want it red. So I save it. It's finished. Then I will say, okay, I need 0.2 and below. Below 0.2. So I just have to give here maybe 0 point, maybe 0. So this is waste. So this is waste. The same way I could have selected everything and then give it as out shell. Then I come back and filter and take 0.2 and above and give it as in shell. It's the same thing. So I just have to select this and say out shell. Let it remain as this. So I'll save it. Now change to your indicator, and they are all your selections. Whatever is gold is red. Whatever is gray is waste. So we are going to use this one to form our solid. Okay, so let me clear it. Now, after you finish your merge table, the same way you did for the shares and lows. This one is just a single wireframe. It's not a vein type that you have series of veins. It's just a single wireframe. So come back to geological model, right click, the new geological model. You remember the share you did cell underscore share. Then when you were creating the geological model, you selected that. Yes, the pyrite, you did cell underscore pyrite. Then you selected that when you were creating that. Same thing applies to the load. So now we did this, we name it indicator. So we're going to pick the indicator for the base lithology column. So this is what we did for the pyrite, cell underscore pyrite, when we're creating the pyrite boundary. This is what we did for the shear, when we're creating the shear boundary. This is the loose. And now this is the indicator. So we are creating the indicator boundary. Just want to put this on 10. I want it to be inside, when to take the extents of the shear. Just want to give that extent. So I can say indicator. So your indicator, I told you that here, if you have, for instance, we have cat 2, cat 3, cat 5. Maybe you have filtered, you have queried out only cat 3. So here you have to set the filter so that you look at only cat 3. If it is cat 2, same thing. So that is the essence of the filter. This one defines the wireframe at the edges where it should give you smaller wireframe, it gives you. It should give you bigger wireframe, it gives you big. I mean, triangles give you bigger triangles. It demands smaller triangles, it gives you smaller triangles. So okay. Okay. So this is your geological model. This one is not vein. The vein method whereby we have to add lithology and create the vein, and then before we create the various domains. So this one is just a single lithology. So here, from the surface chronology, when you right click, remember when it was domain, this is what we use for a new vein system. Then we came and created the new veins from base lithology. But this one is intrusion. So I just have to come to new intrusion from base lithology. When you come in, delete this one before. Okay. So when you right click, come to new intrusion, base lithology. There are only two things, in shell and out shell, and this is what you want. The youngest lithology is always the in shell. The reason is, you know, the mineralization came. I mean, aha. I hope you've heard Bishop. Aha. So the mineralization came later. So that one is the youngest lithology, and whatever is outside is the out shell. Okay. So that is it about this, and this is the name of the annual football points for that one. So you just have to okay it and let it run. When it's done, it will appear inactive, and your solid will be under the output volume. So you have to get that, you have to double click and then activate this. Then you OK it and wait for the output volume. So this is your solid. When you get it something like this, to make it something like this is not, look at this. If you can see my cursor, this one, it's not realistic. So you need to introduce some parameters. The earth is not cyclic, or it's not a circle. It's spherical, or ellipsoid. They have, when you in leapfrog terms, they'll say spherical, something like this. It's not realistic, so you have to introduce a trend to the model, so that it will assume the strike of the orbit. I mean, the shapes will assume the strike of the orbody. So that's what we're going to do next. And if you look at the out shell, see that this is the land, or the concession, where, or the adjacent rocks where this has come into being. So this actually is younger than the surrounding. So that's the post the Bishop was talking about. So that is the solids, SASI solids. So let's do let's introduce the trends. Usually, if I have constructed the vein, for instance, I would like to use the reference surface for one of them. Can use the major one just to reference it, to mimic the attributes of the ore body. This one possesses the strike and the depth of the ore body. So I just want to use that. So to do that, need to come to structural trend. The structural trend. Just right click and add new trend. You have structural trend and global trend. If I don't have any, reference surface from any of the major solids, I just have to introduce global trend. But I have, so I just want to create the structural trend. So you come to the structural trend, leave it as non-decaying inversion, then add. If you click on this, that is add. So you're going to pick the main trend, this reference surface. I'm picking this, and I'm adding. The strength of how stronger the structural trend is depends on the strength value. Experience, it doesn't go beyond 6. That is what experienced people see. So I just have to put 6. I can leave it at 5, but I just have to put 6, and then OK it. Let it run. So this is how it looks like. And that is what you are going to use to direct the solids. That is what you use to direct the solids. Okay, so if you double click on this, you've already dealt with this and this. You can leave this one. There's not a vein method, so I just have to come to trend. This is where you can use. You just want to change it from circle. A circle to ellipsoid or spherical. Yes, that is the geostatistics term. Isotropic to anisotropic. Isotropy and anisotropy, the geostats term. Yeah, so if you want to change it that way, this you can just the ellipsoid ratios. You just the maximum be 3 and the minimum, intermediate 2 and the minimum 1. But we have created a structural trend. So we'll come to surfacing and then we'll click on additional options. The additional options. Yeah.
The trade that you're talking about, is it the left hand where you use the thumb, the middle?
Yes, yes, the Z in the estimation.
Yeah.
Yes, for the ellipsoid. Yeah, that is what it is. But ellipse we say maximum, intermediate, and minimum.
So that gives you the ellipsoid. Yes.
The orientation. So I hope you've heard what we've discussed. This one, when we get to barography, you will understand it better than at this stage. Okay. So just go to interplant and change it to spherical. That's the ellipsoid format. The Earth is not a circle, so you just have to make it ellipsoidal form. Change it to ellipsoidal form. And so that is that. Then you OK it. I think it will take time. It will take time to run. I should have explained this. Okay, so this cell and then the range, when we get to the estimation, you will understand it far better than this stage. But this is not real. I mean, for leapfrog modeling purpose, this is not the real geostar cell and the range. So when we take a load to estimate, then I'll explain for you to understand better than at this stage. So the next wireframes we will construct will be the new renal-based function interplant and the new indicator renal-based function interplant, so that we draw our curtains close to leapfrog wireframes, and then we'll go into, we export our wireframes into data mine, run our geostars in the supervisor, run all the geostars in supervisor, then we send them into data mine for our estimation. We have 6 minutes to go. So if by 5 it's not done running, we may have to view it the next section. Yes.
training. Training. We are doing training.
Okay, guys, we will view it the next section there. It's time.
Okay, sir.
Have a nice time.
All right. Thanks for very much. Thank you very much, sir. For a very nice session.